Hello everyone, welcome to my video. Today I will be discussing the second question on application of differential equation. So the question goes like this. You are given a tank which is of a cylinder form with having a base area of 2 meters square. So from the first sentence, sketch a diagram. So important to sketch your diagram so that it gives you a better idea what to do. So the first thing I'm going to do is just sketch a simple sketch of the diagram. Alright, need not be perfect. So long as it looks like a cylinder, that's fine. So we're given this area here is 2 meters square. So basically the base is actually a circle. So the base area is 2 meters square. And then following the second sentence, the water is poured at 0.02 meter cube per second. That means water is entering the cylinder. Of course, we have seen from the top. The amount of water entering, let's use it. This is the rate per second. So we can write a dV entering or VI going in dt. So I for in, going in or input 0.002. Not necessary put in unit because all the units are consistent here. We're all dealing in meter, meter square, meter cube. That's fine. And then following that, it leaks from a hole at a rate equal to this. So rate here means the dt with respect to time. 0.0004 times the depth of water. Alright, so once the water goes in, the water leaks out. Obviously the water going in is greater than the one leaking out. So the one leaking out is given as, let's assume it's from the base. So we use the symbol for V volume, O for out. So leaking out at dVO dt. You're given that is 0.0004 times the depth. So let's call the depth as h lah. Anyway, it's labeled as h already. So let's say this is the water level. This is h. So that's the water level. Alright. Then the next thing we want to do is we want to be able to show that the differential equation looks like this. So to start off, what's important is the rate of water increasing in tank, rate of water increasing in tank is equals to rate of water entering minus the rate of water leaking. So remember this, in order for the water to go up, obviously the water entering has to be more than the water coming out. Alright, so we know that the rate of water in the tank, the volume of water in the tank is described as V. So rate of water increasing in tank is dV dt. And rate of water entering, we already have it, is dVi dt minus rate leaking out. So this is a very important expression, just remember that. 0.002 minus 0.0004h. Now, you will notice that V is the volume. Volume of water depends on the height of water and depends on base area. So, because the water takes the shape of the cylinder, so we are talking about volume of cylinder. So we know very well that volume of cylinder, which is V in this case, can be given as pi r square h. Now we know that pi r square is the area of the base, which is 2. So this is pi r square. So let's replace it. So we have 2h here equals to this. Right. Next part. Because 2 is a constant here, we can divide everything by 2. And that gives us the answer that's required. Or that's shown in the question. There you are. See this? So we got the answer already. So the next step is we want to solve this differential equation. To do that, we need to separate the variables. So before we separate the variables, you will notice that on the right hand side we have decimal places here. So this kind of complicate solving. To make it easier, we make it into a nice fraction. Over here, this is over 10,000, so we change this to over 10,000. So basically, denominator combined together will be 10,000. So this one becomes 10. 10 over 10,000 is 0.001. And this one becomes 2h. Okay? After we have done that, making it easier to work with, we separate the variable. So once you separate the variable, let's do it slightly below here. So bring the term over, the h term over. You notice I can factor out the 2, so it becomes 5 minus h. And the right side becomes just 1 over 10,000, which is the same as 10 to the power 4 dt. Integrate both sides. Next, we look for what limits to put in. Now, if you look carefully, the tank starts empty. That means at time t equals 0, there's no water there, so volume is 0. So in other words, if the volume is 0, there's no height. So t is 0, volume is 0 means height is 0. So when time is t, height is height. Next step, we integrate. Notice you will get this modulus 5 minus h. Now the question now is to put a bracket. Because negative half is a constant, let's leave it outside and put a limit here. For that matter, this one too, once you integrate, it will look like this. And the limit is 0 and t. Alright, always put the limit. So next step, we are going to substitute everything here, the limit. So substitute the limit first. Remember, even for values of 0, we have to substitute. Like in this case, we have a value of 5 when you put h at 0. On the right side, we have a value, we have an expression that looks like this. 0 will give you 0 in this case, but not in this case. And then we combine it. Bringing in a negative sign will give us a term that looks like this. And we can put in the limit at the same time. Oh, sorry, no more limit, we've done that already. So once you've done that, simplify already. We can simplify further. Notice this is 5,000. Done. Now, how do we know we have done that part? Question says find an expression. Okay, the keyword is expression for the depth of water after t seconds. So it doesn't say that you have to find h in terms of t. Just tell you to find a relationship between the depth and the time. Next step, when will the depth of water be 1 meter? So when h is 1 meter, let's substitute in everything. We would have 5,000 on the left, ln 5 minus 1, so that is 5 over 4 equals to t. So t is actually 5,000 ln 1.25. That gives us the final answer rounded up to be 1116. And the units is in seconds. There you are. Alright. Thank you for watching. That's all for today. Bye.